This is a transformer. In a simple way, it can be described as a device that step-up or step-down voltage. In a step-up transformer, the output voltage is increased, and in a step-down transformer, the output voltage is decreased. A step-up transformer will decrease the output current. A step-down transformer will increase it. This keeps the system input and output power equal. The transformer is a voltage-controlled device. It is widely used in AC power distribution and transmission. Michael Faraday first discussed the idea of a transformer in 1831. Many other prominent scientists later developed it. However, the general purpose of using transformer was to maintain a balance between the electricity that was generated at very high voltage and consumption, which was done at very low voltages. So what is a transformer? A transformer is a device used in the power transmission of electric energy. The transmission current is a C. It is commonly used to change the supply voltage. It keeps the AC frequency between circuits the same. The transformer works on the basic principles of electromagnetic induction and mutual induction. So what are the types of transformers? Transformers are used in power generation, distribution, transmission, and energy use. There are many types of transformer. They are classified by 1. Working voltage range. 2. Working medium used in the core. 3. Winding arrangement. 4. Installation location. Based on voltage levels, commonly used transformer types, depending on the voltage, are classified as 1. A step-up transformer. They are used between the power generator and the power grid. The secondary output voltage is higher than the input voltage. 2 inches, step-down transformer. These transformers are used to convert high voltage primary supply to low voltage secondary output, based on the medium of core used. In a transformer, we will find different types of cores that are used. 1. Air core. Transformer. The flux linkage between primary and secondary winding is through the air. The coil or winding wound on the non-magnetic strip. 2. Iron core. Transformer. Windings are wound on multiple iron plates stacked together, which provides a perfect linkage path to generate flux. Based on the winding arrangement 1 point, autotransformer. It will have only one winding wound over a laminated core. The primary and secondary share the same coil. Auto means self in the Greek language. Based on the installer location 1. Power transformer. It is used at power generation stations as they are suitable for high voltage applications. Second, distribution. Transformer. It is mostly used at distribution lanes for domestic purposes. They are designed for carrying low voltages. It is very easy to install and characterized by LOW magnetic losses. Third measurement. Transformer. They are mainly used for measuring voltage, current, and power. Fourth, protection. Transformer. They are used for component protection purposes. In circuits, some components must be protected from voltage fluctuation, etc. Protection transformers ensure component protection. So now let's talk the working principle of a transformer. The transformer works on the principle of Faraday's law of electromagnetic induction and mutual induction. There are usually 2 coils, the primary coil and the secondary coil, on the transformer core. The core laminations are joined in the form of strips. The two coils have high mutual inductance. When an alternating current passes through the primary coil, it creates a varying magnetic flux. As per Faraday's law of electromagnetic induction, this change in magnetic flux induces an EMF, electromotive force, in the secondary coil, which is linked to the core having a primary coil. This is mutual induction. Overall, a transformer carries out the following operations: the transfer of electrical energy from one circuit to another, transfer of electrical power through electromagnetic induction, electric power, transfer without any change in frequency. Two circuits are linked with mutual induction. This figure shows the formation of magnetic flux lines around a current-carrying wire. The normal of the plane containing the flux lines is parallel to the normal of a cross-section of a wire. This figure shows the formation of varying magnetic flux lines around a wire wound. The interesting part is that the reverse is also true. When a magnetic flux line fluctuates around a piece of wire, a current will be induced in it. The major parts of a single-phase transformer are: 1. The core. The core acts as a support for the winding in the transformer. It also provides a low reluctance path to the flow of magnetic flux. The winding is wound on the core, as shown in the picture. It is made up of a laminated soft iron core in order to reduce the losses in a transformer. The factors, such as operating voltage, current, power, etc., decide core composition. The core diameter is directly proportional to copper losses and inversely proportional to iron losses. 2. Windings. Windings are the set of copper wires wound over the transformer. Core. Copper wires are used due to the high conductivity of copper minimizes the loss in a transformer, because when the conductivity increases, the resistance to current flow decreases. The high ductility of copper is the property of metals that allows it to be made into very thin wires. There are mainly two types of windings: primary windings and secondary windings. Primary windings. This is the set of turns of windings to which the supply current is fed. Secondary windings. This is the set of turns of winding from which output is taken. The primary and secondary windings are insulated from each other using insulation coating agents. Third, insulating agents. Insulation is necessary for transformer to separate windings from each other and to avoid short circuits. This facilitates mutual induction. Insulation agents have an influence on the durability and stability of a transformer. So I hope by now you understand how a transformer works, what they are, and their types. If you found value in this video, please slash on the like button, share, comment, and subscribe for more electronics content. Have a wonderful day, peace, and love.